This lesson is on linear equations in two variables and their solutions. So first, just looking at an equation with two variables, obviously means we have two unknowns, an x and a y generally, but it could be any two variables. And our equation is broken up by the equal sign into two sides. So you can see here we've got an equal sign, so we have two sides of the equation. Any values that we can plug in for x and y that make the equation true, meaning the left side is equal to the right side, that would be considered a solution to the equation. So anything that satisfies the equation is the solution. When we graph an equation, we're graphing all of the xy points that are solutions to the equation. If the equation is linear, we should be able to write it in this form, standard form. So standard form is when you have a coefficient, meaning the number in front of the variable, and times x, plus a coefficient times y, and then separated by the equal sign, and then we have c, which is just some constant, which is just a regular number on the opposite side. So if it's linear, that means when we graph it, the line we make is a straight line as opposed to, say, a wiggly line or anything like that. This is standard form. We're going to learn how to graph in standard form and in slope-intercept form as well as we move through this week's content. So first, we're just going to determine whether or not, if I were to graph this line, if 2, 1 would be a point on this line, or if 3, -4 could be a point on this line. It's possible that they both are, it's possible that neither are, and the way that we check it is we know that every coordinate is an x, y coordinate, meaning in this equation I have 2x plus y equals 5, and I'm going to replace x with 2, and I always replace in parentheses. I'm going to replace y with 1, and then I'm going to see, this is a question mark, does it equal 5? So if it does equal 5, then at the end I will say yes, it's a solution. So 2 times 2 is 4, plus 1, I am still asking, does it equal 5? Notice I haven't done anything to the right side, I've just kept it as 5. 4 plus 1 is 5, 5 equals 5, so yes. For my other point, I'm going to again replace x, in this case with 3. I'm going to replace y with -4. I'm going to ask, does that equal 5? 2 times 3 is 6, plus -4, does that equal 5? 6 plus -4 is 2. 2 does not equal 5, so if I were to graph this, no, 3, -4 would not be on the line. So this gives you an example visually, because obviously we just did it algebraically. We plugged in the values, we found yes for the first point and no for the second. But here you can see this is the graph of the line, and it's the same graph over here. It looks a little bit different because I zoomed in differently, but this is the same line in both of these equations. Notice it does go through the point 2, 1. It does not go through the point 3, -4, which is why this one worked out algebraically and this one did not. Go ahead and try these two on your own and then press play to see how you did. So for my first one, I've got 4 times x, and instead of x, I'm replacing it with 3, minus y, so I'm subtracting a -1, equals 5. Very important that we plug things in parentheses. 4 times 3 is 12. Over here, minus and -1, we're going to do that ching-ching trick or keep flip change, because now this is actually a plus 1. And I'm asking, does that equal 5? 12 plus 1 is 13. 13 does not equal 5, so no, this is not a point on the line. For my second, 4 times 2 minus 3, does that equal 5? 4 times 2 is 8, minus 3. Again, I'm asking, does it equal 5? 8 minus 3 is 5, and 5 does equal 5. So yes, 2, 3 would be a point on the line.